So, kind of the main objective I want to focus on today is providing some pretty broad overview of what seismic certification is, why it's something we consider within our building codes, then get into the manner of actually providing product certification, and ultimately how we would actually deal with projects that require certification in terms of laying out sort of a framework for who needs to do what and whose responsibility is what within the overall project process. So I think Maria kind of covered all the first couple of slides, but been very active within the seismic certification world, both from a nuclear power and nuclear research facility standpoint, as well as the kind of IBC compliance, California hospital projects, as well as military certification projects, as well as being pretty involved within the building codes itself. One item to point out, sort of the last bullet point there in code committees, one of the things that's been sort of in the works for about the last year and a half, 2 years, is ASCE is actually spearheading an effort to create their own document that's going to basically become the new seismic certification standard. So it's still in the works, but is intended to replace what we've seen within the ASCE 156 seismic certification standard, and actually become more of a independent ASCE document. And that should hopefully be coming out the next couple years. So within kind of my background, by training, I'm a structural engineer, but have been very involved in critical facilities throughout my consulting career. And so we do a lot of work in kind of more high value facilities, which is a lot of where certification comes into play. But there are also need for project or for seismic certification with our current building code, really in any building for certain types of systems. Most people think of seismic certification more on the well, most people tend to attribute it to California and the OSHPD jurisdiction for hospitals, but there's a lot of standards, everything from military, life sciences, healthcare, and then conventional buildings where there is certification requirements. So we do all of our actual certification through a subsidiary company. It's a product certification agency where we've done a substantial amount of testing and certification of products over the last 8 or 9 years. As well as operating a 10 by 10 triaxial shake table that's located in Minneapolis area. So to lead into what we think of from a seismic certification standpoint, you know, it's kind of one of those, I always kind of laugh, but it's a structural engineer's job to deal with non-structural systems, which, you know, kind of sounds like an oxymoron to a certain extent. But non-structural products and kind of the design considerations for earthquakes for non-structural systems tend to be something that we really don't focus on teaching people about during their academic career. And kind of non-structural considerations are really historically a kind of learned on the job bit of knowledge. And so with that said, you know, it's sort of important to understand what a structural engineer's responsibility is within a non-structural design, and also understand kind of how we delegate that work. But when we talk about non-structural components and seismic performance, historically, we think more of the position retention and sort of anchorage and bracing of components as what most people think of for non-structural components. And so within our building code, you know, that's required for basically the vast majority of buildings we design, but most structural engineers sort of punt that to the installing contractor sort of as a delegated design item. But we've experienced, you know, over the last years, and most of these photos are relatively recent earthquakes, you know, we've seen firsthand the failures that we've seen for non-structural components. And the ones we normally see tend to be you know, components that weren't anchored or were improperly anchored, and obviously their failure can definitely pose a life safety hazard, and is obviously why we're looking at the anchorage and bracing. But the sort of design consideration of the component itself and the performance of the component itself is sort of outside the scope of those conventional projects. So we look at why we care about the non-structural anchorage and why we care about how much, how they perform in an earthquake. You know, number one is we want to make sure that they do stay anchored, so we don't have any sort of life safety hazard posed by non-structural components.